Elasticity. After withdrawn the external force, the body or object regain its original position is called elasticity. After withdrawn the external force, the body does not regain its original position is called plasticity. The opposite of elasticity is plasticity. Example of elasticity is rubber band. If we give a force to the rubber band, it will extend. After withdrawn the force, the rubber band come to the normal size, but the spring does not regain its original position. Stress. When a force is applied on a body, there will be a relative displacement of the particle. Due to the properties of elasticity, the particle tends to regain their original position. So, stress is defined as the restoring force per unit area. What is restoring force? Restoring force is a force which acts to bring a body to its equilibrium position. So, the first diagram shows one end of the spring is fixed, another end the weight anchor attached with the free end. Due to the weight, the spring move downward direction. The restoring force try to move its equilibrium position. So, ஒரு ஆப்ஜெக்ட் அதோட ஈக்லிபிரியம் பொசிஷனுக்கு வரதுக்கான தேவைப்படுற அந்த விசையை தான் ரெஸ்டோரிங் ஃபோர்ஸ்னு சொல்கிறோம். ஓகே, we have two type of stress. One is the normal stress, another one is the tangential stress. Normal stress. The restoring force per unit area perpendicular to the surface is called normal stress. Restoring force parallel to the surface per unit area is called tangential stress. So, perpendicular to the surface area is normal stress. Parallel to the surface area is tangential stress. Strain. That under the stress, the body become deformed. The quantity that describes this deformation is called strain. So, the strain is given as fractional change in either length or volume or geometry. Strain is a dimensionless number. What is the relation between stress and strain? Stress is proportional to the strain. It obeys the Hooke's law. The slope is Young's modulus. In this region, the material undergo only the elastic deformation. The end of the stage is initiation point of the plastic deformation. We have three types of strain. One is longitudinal strain, shearing strain and volume strain. Longitudinal strain. Consider a wire of length L and diameter D. We apply a force on both sides. The length is increased and the diameter is decreased. So, this is longitudinal strain. The ratio of change in length to the original length is called longitudinal strain, small l by capital L. Change in length by original length. Shearing strain. So, this is the second diagram. It shows the surface AB is fixed. A force applied parallel to the surface CD. The body is sheared by an angle theta. The angle theta is measured in radians is called shearing strain. So, shearing strain is defined as the angle of shear measured in radians is called shearing strain. Next one, volume strain. The ratio of change in volume to original volume is called volume strain. That is small v by capital V. This is a V. The force is applied due to the stress. dV is the change in volume. Elastic limit. So, in the graph shows graph drawn between force and extension. That arrow mark, blue color arrow mark indicate the elastic limit. Below the elastic limit, the particle or object regain its original position. That is elastic deformation. Above the elastic limit, the particle or object does not regain its original position. So, this is the elastic limit. This is the initiation point of plasticity. Difference between stress and strain. Stress, the restoring force or deformation force per unit area. Stress is force by area. Unit is Newton per meter square. Strain, the change in shape per original shape is strain. That is del L by L. It has no unit. Thank you.